Hi students, very good morning to all. I welcome you for the physics video session. So this is your physics teacher Pontiraj. Before going to the today's session, we analyze our physics syllabus because due to the lockdown we have received a new syllabus, that is revised syllabus has been published now. Here some of the portions has been deleted from the original syllabus, and previously we have 160 periods of teaching, now only 131 periods of teaching. So we have some of the portions deleted in some of the chapters, not in all chapters. So most of the chapters has deletions. So we will see the what are the portions deleted. Before going to that, we recall the syllabus. So we have 10 units, 15 chapters are there. So first unit, physical world and measurement. The physical world already we finished, so only the introduction point of view physical world is there. What do you mean by physics, what do you mean by scientific methods, and what are the basic things, and what are the fundamental forces in nature. So only that question, fundamental natures in force, is the question to be asked in the exam point of view. Remaining things are only for understanding purpose. No more questions can be asked for exam. Second unit, units and measurement. So there is no deletion in this lesson, chapter 2. And chapter 3, 4 are motion in straight line and plane. So fifth one is the laws of motion. So these are about the mechanics. What do you mean by displacement? What are the basic formula and derivations of derived quantities like velocity, momentum, linear momentum, angular momentum. So these and all going to be discussed. Fifth one is the laws of motion. Sixth one is the work energy power, and the eighth one is the gravitation. So gravitation, work energy power, laws of motion, these and all we have started in 9th standard science also. So we have the basic knowledge about it. And seventh one is the system of rotational motion. We well known about the linear motion and two-dimensional motion and circular motion. So here rotational motion of the particles. Chapters 9 to 11, the properties of matter. So what do you mean by matter? Matter means solids, liquids, gases and plasma. Solids and liquids also called as fluids. Those properties of materials, that is mechanical properties, are going to be studied here, and the thermal properties of matter, all things also discussed. Chapter 12 is thermodynamics. So full of about heat. The heat is how it is conducted from one place to another place, like that. And chapter 30 is kinetic theory of gases. So the behavior of gases, the behavior of atoms, molecules inside the gases, and what do you mean by ideal gas, gas equations. So this and all going to be studied. And the last unit has 2 chapters, oscillations and waves. Waves we know, electromagnetic waves, mechanical waves. Sound waves already we have studied, it is a mechanical wave. And electromagnetic waves, most of the waves we are using for the communication purpose, radio waves, microwaves, infrared, these and all called electromagnetic waves. The basic for the waves is oscillation. So oscillation is the transfer of energy from one place to another place. So these and all we are going to study in the 11th physics, and this very fundamental and very few less important topics only deleted, and mostly core part will be the same. So we should be ready for majority of the portions are the same as in the previous syllabus. So this is very fundamental to the 12th standard and also the higher studies. So now let's move to the what are the portions deleted in the previous syllabus. So here the chapter 1, so fully it's a conceptual understanding purpose only, not for exam point of view. We may take it for only one questions, what it is, that is what are the fundamental forces in nature. 4 forces are there now, so that only enough for examination point. So remaining will be omitted in the physical world. So chapter 2 there is no deletion. Currently we are seeing the units and measurement, that is the chapter 2. And 3, motion in a straight line, yes, some of the topics. And 5th, so majority of the topics in deleted. 7th, 8th, 9th and there is no deletion in the 6th and 10th and 14. So only some of the topics, so about 20% has been deleted, and we will see briefly when we are studying about individual chapters. So some of these topics should be passed over in book, so I will tell you later, students. So now let's move to the today's session, that is units and measurement, part 4. In this session, so this is the part 4 of units and measurement. We are going to see the accuracy and precision. So what do you mean by accuracy and precision? Already we might be heard about these words like what an accurate result and what a precise value. So already this and all we have used. So let us see how what is actual meaning of these things in our physics concept. So first one is, before going to that, we should know the meaning of resolution or accuracy of the instruments. So we are using the various instruments for measuring the physical quantities. Suppose you measure the length of any material, you use the meter scale. It's made up of wooden or that is plastic scales we are using in the school days. So in order to measure the length, so meter scale has each 1 centimeter is divided into 10 divisions. So each division has 0.1 centimeter. 1 by 10 centimeter equal to 0.1 centimeter, which gives, that is 1 millimeter. So it is the resolution or accuracy of the meter scale. So we can measure the length, any length, in the accuracy of 0.1 centimeter. So this is the least value that can be measured by this meter scale. So this least value is called least count of the devices. So also it is called resolution or accuracy. So we can take the readings up to the accuracy of 0.1 centimeter. So for example, length of the any device may be 2.5 centimeter, 4.2 centimeter, 3.7 centimeter, like that. So this is 0.1 digit, that is 0.1 centimeter. So while we using the vernier calipers, so it is a device used to the length, breadth, depth, inner radius, outer radius, diameters of the materials. So this is the vernier caliper. Here there's two scales are there. One is the main scale, similar to the meter scale, and another scale is called the vernier scale. So by using both scale, we can have the measured values of resolution or accuracy to 0.01 centimeter. So it is a more accuracy than the meter scale. So we can measure even in the resolution of 0.01 centimeter. For example, 2.45, 3.72. So after the decimal point, 2 digits are there. So that accuracy level we can measure the readings. And while we using the screw gauge, this is the screw gauge. So this is same purpose for length, breadth, diameters of the materials can be measured. So whose resolution is 0.001 centimeter, which is equal to 0.01 millimeter, 0.0101 millimeter. So this is more accurate than vernier caliper and meter scale. So this is called resolution. So students, you may know what do you mean by resolution or accuracy. Both are same meaning, and which is called least count of the material also. Least count means least value that can be measured by the devices, instruments. So by understanding accuracy of a measurement is how close it is to the true value. So the measured value, the measurement is how close to the true value. We know the true value of any physical quantity we have to measure. So the measurement or taken measurement should be very close to the value. So that is called more accuracy. So we can define the accuracy. For example, measurement of John measures the amount of tea in his mug 3 times. He obtains the value 119 ml, 116 ml and 115 ml. So the actual amount of tea is 120 ml. So measured value of 3 times is 119, 116 and 115. Here you compare these things. They are 119 ml that measurement is very close to the original 120 ml. That is, true value is here 120 ml, but measured value in first time is 119. It's very close to 120 ml. So 190 ml, the first measurement is the accurate, more accurate, and the 115 ml is very away from the original value, so it is called least accurate. Next, precision. So precision means how consistent a series of values are with each other. So if we are taking the more number of measurements in a single physical quantity, so we have the many measurements are there. The how closeness, consistency of between the many readings, between the more readings is called the precision. Here the same problem, that is the same amount of tea, the original true value of mug is 120 ml. So it is measured in 4 trials. So first trial 100 ml and 101 ml, 102 ml and 101 ml. So comparing these things, the accuracy will be very poor because true value is 120, but measured values are from 100 to 101. So difference will be very large. So it is less accuracy. But by looking the difference between the readings, the very few difference. So 100, 101, 102, 101 again. So the consistency will be more, that is difference will be the very less. So it is called precision. So it is called very close to each other. So it has more precision, or precision is good. If the consistency difference is between the readings will be more, then it is called less precision. Here another way of understanding the precision and accuracy. Suppose a rod AB is given to a student and measured to find out the value of length. So but we know the true value of length will be 3.678 centimeter. That is called a true value, original value. If we are measuring, the student may be using the meter scale in the first time, so it gives 3.5 centimeter. We know the meter scale 0.1 centimeter accuracy. So after the digit decimal point, only one digit is there, so it may be 3.5 centimeter. If the students using the screw gauge, so it gives the value of 3.38 centimeter. So comparing both, so original is 3.678 and by meter scale 3.5, this is 3.38. So 3.5 is close to the original true value. So meter scale given by this reading is more accuracy, but compared to the resolution, so the screw gauge gives the it has more resolution compared to the meter scale. It gives the result in 0.01 centimeter accuracy, so it is called more precise. So meter scale is called more accuracy and screw gauge given reading is called more precise. So just you differ between the accuracy and precise. Next, let us see errors in measurement. What do you mean by errors? So there is a difference between the original value and the measured value. So that is called error. Suppose you, due to the lack of concentration, due to the technical problems, or due to the carelessness, or due to the surroundings, due to the atmosphere, so this and all error may be arrived. So we can calculate the errors in each measurement. So errors generally broadly classified into two categories: systematic and random. So what do you mean by systematic and random? Systematic errors due to the definite cause and which follow a particular rule, that is called systematic errors. So it is the one dimension, so it is linear, it has positive or negative values. The systematic errors also divided into three categories. First one is the instrumental error. So it arises due to the imperfect design or calibration of the instrument. So suppose we example, zero errors in the screw gauge and vernier calipers. Suppose the screw gauge or vernier are having the errors, so the measured value will be has some errors, so it is a not accurate value. So this is called instrumental error. And another example, that is due to rise in temperature, due to the conditions, external conditions like environment, changes in temperature, pressure, humidity, there will be in rise in temperature, so a scale, wooden scale get expanded, and this results in error in measurement of length. So these and all also called the instrumental error. So simply the errors created due to the instruments, that devices that we are using for the measuring the physical quantity is called the instrumental error. Here second one is called imperfection in experimental technique or procedure. So here the errors due to the experimental arrangement, the procedure and techniques are called imperfections. So these are also called as errors. That is, suppose to determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual temperature of the body. So this is also called the imperfection. So this is the lack of experimental technique. And another example will be, that is while we were weighing the low density materials, like the cotton or very precise value materials like gold. So this and all should be measured in a vacuum area or the closed area, because due to the buoyancy of the air, the result will be affected. So these and all also called imperfections in the experimental techniques or procedures. So this is also called errors. This fall under the systematic errors. This can be so simply systematic errors can be estimated and can be corrected. So third category is the personal error. So it arises due to the carelessness, there is lack of proper settings of the apparatus. So due to the personal mistakes, so it arises the personal errors. For example, if you hold your head towards right too far while reading the position of a scale, then an error is introduced due to the parallax. So this is to be noted while taking the readings. So you should always look at a straight in front of the any scale. So this is also called a personal error. The second category is random errors. So random errors is, so it randomly produced irregular errors. So they are uncontrolled disturbances which influence the physical quantity and the instrument. So random errors is inversely proportional to the number of observations. The random errors may also arise due to the random and unpredictable variations in experimental conditions, that is temperature, pressure, voltage supply, due to the vibrations. So they also known as the chance errors. So when the person repeats the observations, if you take more and more readings, he may get different readings every time. So this is called random error. Another category of error is called least count error. So this error is associated with the resolution, that is accuracy of the instrument. We know the least count of the instrument. What do you mean by least count, students? The least count means the least value that can be measured by the any instrument is called least count of that instrument. For example, for screw gauge 0.01 millimeter. So very resolution and least value. For vernier caliper, least count is 0.01 centimeter. So it is less accuracy than screw gauge. So due to the errors in these devices, the least count values, they are called the least count errors. Next we see some examples regarding accuracy and precision. So the questions may be expected from only this concept, and today we taught, that is the volume of a liquid is 20 ml. A student measures the volume of liquid using a cup and obtains the following results. So here 4 set of readings are given, and the true value is also given. True value of the liquid is 20 ml, and these are the measured values. And comparing the measured values, first take the first set. The first set 4 times the 4 trials can be taken. Here 20 ml, 19.3 ml, 18.8 ml and 18.6 ml. So comparing to the true value, so almost near to the 20 ml. So it is called accuracy is good. Accuracy means how close the measured value to the true value. Here 20 ml also we have, so it's more accuracy, but compared to the individual measurements, so 20 ml and again next to the 19.3 and 18.8 and 18.6, there is a large difference between the readings. So the precision will be very poor. Precision, we know the how close the individual readings. So if difference between the readings will be less, then accuracy will, the precision will be good. Here the difference is large, so precision is poor. So if you take second set of readings, here you look at the 16 ml, 16.1, 16 and 6.2. so these are very far to the 20 ml, so the accuracy will be very poor. But comparing the individual and difference between the readings will be very less, 16 and 16.1, 16 again 16.2. so the precision will be very good, but accuracy will be very poor. In the third set, so comparing the set of readings, so very close to the true value, and also in between the readings a close difference, there is a not much difference, so we may say the accuracy good and also precision good. The fourth category, so 18.6, 17.8, 15.6 and 16.2. here looking the readings, so all readings the average will be very far from the true value, and also in between the individual readings there is a lot of difference, so we can say accuracy and precision both are very poor. So this is the term by means we can understand what you mean by accuracy, what you mean by precision. That's all, students. And another example, so bad eye target. So look at the target. The first thing, the 5 bullets are very far from the center, so the one bullet will be at center, so its very accuracy is good, but precision, other 4 are very far away, so precision will be poor. In second category, the all bullets are in far away from the target and also very close to each other, so it is called accuracy is poor and precision is good. In third category, so all are in different places, so very far to the center also, so we can say accuracy poor and precision also poor. So looking at the fourth one, the all bullets are very close to each other and also in the center of the target, so the accuracy is very good and also precision also good. So in this way we can explain accuracy and precision of the measurement or anything else. So thank you, students.